I am Anil Kumar. Welcome to an optimization calculus question. Let us try to understand the strategy to solve such problems. Sketching and visualizing is an important part of solution. Let us now look in details. How do we develop this strategy of understanding and solving such questions? In case you want to learn from me, you can always join my classes by sending the email on the address given. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss a very important optimization question. It is thinking and application problem. In case you want to learn from me, you can always send an email on the address given. Pause the video, copy the question, answer, and then look into my suggestions. The question here is, a container for wooden matches consists of an open top box to contain the matches that slides in to an outer box, open at both ends. The length of the box is fixed at 10 centimeters to match with the length of the matches. The outer box is designed so that one side completely overlaps for gluing. If the outer box is made from a sheet of cardboard that is 16 centimeters by 10 centimeters, what dimensions for the outer box will maximize the capacity? Extremely important question, which will need some focus on understanding what it says. Once you understand, I'd like you to make a sketch, relate the defined parameters, and then solve. You may have to read the question twice. So what are we trying to do here? We want to make the open box in which the matches can be placed, and the length of the matches is given to us. It is being made from a sheet of cardboard. The outer box is designed so that one side completely overlaps for gluing. Very important line. If the outer box is made from a sheet of cardboard that is 16 centimeters by 10 centimeters, what dimensions for the outer box will maximize the capacity? So think like this. We have one sheet here, which is 10 by 16. So 10 centimeter is the length of each match, right? So you're going to place the matchsticks here, right? Like this in the box. That's the whole idea. So that will be placed after folding. This is the outer cover with which you are making the box. So you could think like this, that the box will be this box is open from the top so that you can put the matches in it. So that is the open box, whose length is 10 centimeters, so that the matches can actually filled in here in this box. Now let us say that the dimensions of this box are x is the width and y is the height. Now remember, we are also saying that one of the side overlaps. The outer box is designed so that one side completely overlaps for gluing. That means let's assume this is an extra side, right? So this length of the strip is folded. You need to fold this, right? So when you fold it, you can divide it into X and Y. This is, let us say, the Y part of it, right? So, and let us say that overlaps. So both these, you started with Y and it overlaps. And then you have this length of X. The drawing is not to the scale, but it is more to explain you the concept, right? So again we have X, and that is the next fold. And then we have X, and that is the overlap. So that strip can now be folded, and you can form a box. So I hope this concept is clear to you. Once you get this, then you can relate X and Y. Because we know that this combination of 3y and 2x is equal to 16, right? So you get one equation from here, which is 3y plus 2x is equal to 16. So that relates x and y, and we need to maximize the capacity. So when you want to maximize the capacity, we're talking about volume. And volume for this box will be what? 10 is the length and the cross section is x into y. So 10xy, correct? So that is the volume. To find the maximum volume, we need to get the first derivative, analyze the critical number by equating the derivative to 0 and find the solution. Is that clear to you? So let's do these calculations now. So what we were saying there, that in this box, we have related x and y with the relation 3y plus 2x equals to 16. And also, we know that the volume is equal to 10 times xy, right? So, referring back to the diagram, I am writing the same equations in the next page. And now we'll do the needful. From the first equation, we could isolate x or y. Let us isolate x. So, from here, we know what x is. X is 16 minus 3y, and then you divide by 2. Substitute this value in the formula for volume. So 10 times 16 minus 3y divided by 2. So that is for x times y. So as you can see, what we get here is the volume function in terms of one parameter, which is the height of this particular box. Perfect. So now we get our relation, which is volume as a function of y. And you can open this bracket. So 10 divided by 2 is 5. And multiplying 5, we can write like this. 5y times 16 minus 3y. You can open this bracket. So we get 80y minus 15y squared. So that is the volume. Now find the derivative. Differentiate with respect to y. So we get 80 minus 30y. Equate that to 0 to get the critical number. So we have y prime equals to 0. That means 80 minus 30y is equal to 0. And that gives you the critical number, y, right? So let's go to the next page, write down the relation. So again, we had the volume, which was 80y minus 15y squared. And when we differentiate it, we get 80 minus 30y. Equating that to 0, we know 30y equals to 80, and that gives you a value of y as 80 divided by 30, or 8 over 3. So 8 over 3 is the only critical number which we have. To analyze this number, you could follow many different methods, whether it is maximum or not. So which one will you prove? Well, is it a maximum? How will you prove that? Now you could analyze the first derivative to prove it. You could also find the second derivative. So what is the second derivative for this? Second derivative is minus 30, which is less than 0. That means that the critical number is a maximum, right? Because less than 0 means opening downwards. And this implies that the critical number represents maximum. Very few students use the second derivative, and that is why in this particular example I have taken that as the proof that this represents second derivative, right? So what dimensions for the outer box will maximize the capacity? We know value of y. We can now find the value of x, right? So x is equal to, as we had said earlier, 16 minus 3y over 2. You can substitute the value. So we get 16 minus 3 times 8 by 3. So 3 cancel. You get 8 on the top divided by 2, which is equal to 4. So you see that. So we got the dimensions of this particular box, which is 4 by 8 over 3. You get this in centimeters. Here is the complete solution in short for you. So we began by understanding that we have this cardboard strip, which is 10 by 16, which we are folding, and that is the overlap y. This is x and this is 10. The whole length of 16 is equivalent to 3y plus 2x. From here we isolated the value of x, which is 16 minus 3y over 2. Volume is product of all the three, 10, x and y. Replaced x with 16 minus 3y over 2 and got the formula for volume in one variable, which is the height of this box. Found the first derivative, and that results into a critical number where y is equal to 8 over 3. Now, and found the second derivative. You see the second derivative is less than 0. Here the critical number is y equals to 8 over 3. Substituting 8 over 3 in the relation, we got the maximum dimensions. So dimensions are that the box will be 4 centimeter by 8 over 3 centimeters. Perfect. So that is how this particular question will be solved. So when you have a word problem, it is better to think through it just as we planned it out. So we began by thinking, like we are given a cardboard box, how should I fold it? Do not forget the overlapping, right? That results into that extra y which we have. Perfect. So that will also result into the two parameters which we have taken, the width and the height of the open box. We have to maximize the volume, so write the volume in one variable, which we did. And now, for maximizing, we know that the first derivative will give us the critical number. We used the second derivative to show that that critical number is indeed a maximum. Now, if you miss this step, to prove that this is a maximum, you might lose a lot of marks. So it's a very critical step for you to do. So I hope you have understood the solution. More than that, the strategy to solve these questions. In case you want to learn from me, you can always send an email on the address given. Explore calculus. I can make it very simple for you. Thanks for your time. And if you like and subscribe to my videos, that'd be great. All the best.